Since quadratic equations contain a term in which the variable is squared, it is often convenient to solve them using the principle of square roots. This principle states that if x squared equals k, then either x equals the square root of k or x equals the opposite of the square root of k. The shorthand notation x equals plus or minus the square root of k is often used to indicate both of these values together. Let's look at some examples of how the principle of square roots can be used to solve quadratic equations. In problem number 1, we have n squared equals 25. Now, it would certainly be possible to solve this equation by factoring. We could subtract 25 on both sides and then set one side equal to 0 and then use the zero product principle. However, since we have a perfect square, n squared, on the left-hand side, let's use the principle of square roots. If n squared equals 25, then we know that either n equals the square root of 25 or n equals the opposite of the square root of 25. And since the square root of 25 is 5, we see that n equals 5 or n equals negative 5. Both those numbers are solutions of this quadratic equation. If we want to indicate them in a solution set, the simplest way is to write plus or minus 5 as our solutions. Let's look at the second example. In this case, we have negative 3x squared plus 7 equals 0. This binomial on the left-hand side is prime. It cannot be factored. So we can't use the zero product principle to solve this quadratic equation. Instead, we'll use the principle of square roots. First, let's isolate the x squared. Let's subtract 7 on both sides. And then let's divide both sides by negative 3 to obtain x squared equals 7 over 3. Now, we can use the principle of square roots to state that if x squared equals 7 over 3, then x equals plus or minus the square root of that number. Let's write that number in simplest radical form. We can achieve this by multiplying the numerator and denominator by the square root of 3. So we have plus or minus the square root of 21 over 3. Those two numbers are the solutions of this quadratic equation. Let's look at two more examples of how this principle of square roots can be used. In problem number 3, we have the quantity y plus 2 squared equals 4. Once again, we could try to solve this by factoring. If we were to write it in standard form, we would have to multiply out the binomial y plus 2 squared and then subtract 4 on both sides. However, since we see that that binomial is being squared, we can apply the principle of square roots. So that if y plus 2, the quantity squared, equals 4, then y plus 2 must equal positive or negative the square root of 4. And since the square root of 4 is 2, we have y plus 2 equals positive or negative 2. This is actually two equations in one. We're saying that y plus 2 equals 2 or y plus 2 equals negative 2. So if we solve each of these equations, we will obtain the two solutions of the quadratic equation. Subtracting 2 on both sides, we have y equals 0 or y equals negative 4. And so those are the two solutions to this equation. Finally, example number 4, we have x squared minus 8x plus 16 equals 90. It's important to note that that trinomial on the left-hand side is a perfect square trinomial, and if we notice that, we can apply the principle of square roots easily in order to solve this quadratic equation. So first we will factor that trinomial as x minus 4 squared. Then we can apply the principle of square roots to say that x minus 4 equals the square root of 90, or x minus 4 equals the opposite of the square root of 90. Then we can simplify the square root of 90, writing in simplest radical form. Notice that 90 is 9 times 10, so we have the square root of 9, which is 3, times the square root of 10. And then similarly we have the opposite of 3 times the square root of 10. Finally, adding 4 on both sides of the equation, we see that we have two solutions. The two solutions of the equation are 4 plus 3 times the square root of 10 and 4 minus 3 times the square root of 10. In the shorthand notation, we can write these solutions as 4 plus or minus 3 times the square root of 10.